Good afternoon. I would like to welcome all the participants and attendees to the second day of the SME Resilience event and to the Change Management in Manufacturing session. My name is Aniko Balogh and I will be a moderator during these sessions. Some of you have already met me and got to know about our project yesterday and today in the morning, but for those of you who didn't, I would just like to tell you some words about ourselves. I represent the organizer project Co-Versatile. We are a Horizon 2020 project supported by the European Commission. The project started just 2 years ago after the breakout of the COVID-19 pandemic, and our aim is to strengthen the adaptation capacity, the resilience, and the flexibility of the European manufacturing sector. Our lives are still affected by the coronavirus pandemic, and it is still a challenge for the European economy and for its citizens. During this health crisis, it was vital that we not only protect the critical sectors of our economy, but also our infrastructure, technology, and last but not least, we need to protect the jobs and the employees. Nevertheless, this economic crisis includes the possibility to adapt to these disruptions in the future. So our project and this conference tries to focus on this last issue. This afternoon and tomorrow, you will get an introduction to the project results and learn more about Co-Versatile's insights in delivering a rapid response to such emergency situations, which I talked about. This afternoon, we will share our results in delivering a rapid manufacturing response to emergency situations and global disruptions. And those of you who were here today have heard Amardeep Banerjee, who was our keynote speaker, and his thoughts and speech included agile manufacturing, which was also an important topic because it goes hand in hand with our session today. So first, I would just like to tell you some words about our agenda. So first, you get an overview about the SME manufacturers and the COVID-19 crisis. And one of our colleagues, Amardeep, will give you the general picture about the state of the art at the moment. Then, the next presentation will be about virtual prototyping and digital twins to help repurposing product design. Finally, the best practice will be introduced, which is focusing on cloud-enabling simulation applications. After that, I will tell you some words about the cooperation possibilities within the project. And from 2:15, you will have the opportunity to visit our digital technopole, which you might have heard about yesterday. My colleague Sebastian introduced it. That is our main meeting place and marketplace within the project. And finally, from 2:30 to 3:30, I will stay here and all of my colleagues will be here at the expo live. So you will also have the possibility to meet us in person, talk about your questions, requests, interest in our solutions, which we are showing you today, and we'll have the possibility to continue our cooperation. So that's it for today, and I'm calling our first presenter to the floor, Amardeep Banerjee, who joins us from the EIT Manufacturing Central. He's responsible for innovation at the EIT Manufacturing Central since 2020. And Amardeep will share with us his insights on the topic of SME manufacturers and the COVID-19 crisis, how it made an impact on the supply chain, and as I mentioned, what are the key trends at the moment. So, Amardeep, please.
Thank you, Aniko. Thank you.
Pleasure
to be here.
Thank you very much.
Try to share my screen. Give me a second. let me know if you see the screen, Aniko.
Yeah, we'll tell you.
Perfect.
Not
So,
yet, not yet. Okay, there it is. You
awesome.
can go ahead.
Thank
Yes,
you. Yeah.
sorry, just a second. In the meantime, if you've got any questions, you can just put it in the comments window on the right-hand side, okay? Thank you very much.
Yep. Okay, very good afternoon. Amardeep Banerjee from EIT Manufacturing. The topic for today is change management, and I'm glad to start this session and talk about the impact of the COVID crisis on the SME manufacturers and what key trends we are facing. Uh, we have we are living in an uncertain world right now. We have new supply chains being established as we speak. There is disruption, there is establishment of new routes, and we need to adapt to this change. And this is what I would like to kind of cover for today, thinking about how could we reimagine our operations, how could we reimagine our workforce, considering this disruption, highlighting mainly digital and technical innovation. This is something which has been going on before the pandemic, and my impression has been that there is an acceleration of digital innovation after the pandemic and other crises, for example, the chip crisis and so on. I would also like to talk about the trends, what is impacting the future of manufacturing, especially in Europe, and then would give some key insights of a pan-European SME survey, which we have done thanks to our partner in France and Slovakia, and finally would give you some relevant EIT manufacturing activities and how you could engage with us further beyond the project as well. So. Indeed. So, in speaking of trends, this has been a topic about emerging markets and evolving demographics in Europe. For example, this has been there before the pandemic as well. But what has changed, from my impression, as well as say the state of the art, is that there has been increasing embracing of digital solutions. There is also a very high reorganization happening of manufacturing assets, especially in the healthcare supply chain. Take into account the ramping up of production for ventilators, masks, which happened. And at the same time, production planning and supply chain planning has to take into account demand disruptions. So this is the underlining, I would say, shift which is happening, but at the same time there is a macroeconomic and more of a overarching global change happening in terms of trade, in terms of personalized experiences and a trend towards manufacturing as a service. So it has to be seen holistically, and indeed there is technology from 5G to blockchain to cybersecurity, all of which is not traditionally coming from a manufacturing setting but is impacting manufacturing. So the key message here is that these disruptions and trends are shaping the future of manufacturing across sectors, be it textile, be it pharmaceutical, be it healthcare. But at the same time, I think the healthcare supply chain and the healthcare manufacturing industry, be it vaccine productions or mask or ventilators, are very much impacted by it, which means as well that the employees and the real people, production is a people's business. So they are impacted much more. So how do we help the employees from this sector to embrace digital solutions, and especially the hidden champions in Europe? How do we make sure that they are ready to take the change is something we have to keep a watch for sure. And we did an exercise at EIT Manufacturing across our network from Poland to Belgium, and from Serbia to Greece, as well as from Sweden to Portugal. This is where we are spread across, and we got together in a working group and thought about, okay, what does future of manufacturing look like in 2030 for Europe, and what are the 3 or 4 key things which is something which would keep the manufacturing ecosystem here unique as well as competitive. And what we came about was that it's definitely a need for circular economy and sustainable solutions. How could we do more with less? How could we connect what is already connected or interconnected? Speaking about data sovereignty, speaking about flexible supply chains, and at the same time, how could we also have better working conditions and better social implications for people in the manufacturing industry. So this was our key findings from this working group, and we are still working on this aspect at EIT Manufacturing. And if I have to maybe quickly jump to a quiz, which should be coming to you. You can take your time to come to answer it. Think about from a customer perspective. Think about from your department. Think in your ecosystem. Which of the topics are the most relevant for your industry? Is it about repairing? Is it about hyper localization or circular manufacturing, or is it an increasing trend towards new materials and economy of intangibles? You can, if you say that there's okay, none of these and there's another trend or another topic which is very relevant for you, please feel free to use the chat. We can have say a collection of other topics also which are relevant for the industry, and the main message here is that you get some takeaway, and also like in terms of consensus, if what's the trend, is it really what my industry thinks, right? And maybe if I speak to now my other contemporaries, then maybe it's something else. So this is a small quiz which should be there in some time. And I'd like to jump into the project Coversatile. This is a project which you have been listening to. This is the Matchathon. Today you had this session in the morning about agile manufacturing, and I think it's quite relevant. The agile manufacturing is very much related to all the work packages we have here, starting from adopting manufacturing process for upscaling, or be it product or process certification, reconfiguration of supply chains, and workforce ramp up. And from say the theme perspective, I feel the workforce ramp up and future of work is the closest to change management in manufacturing. And there are certain, I would say, critique as well of change management and agile, that this is again very much coming from the Silicon Valley and from the software world. But to be honest, this has been countered with as well with the COVID crisis. We see that there is a high need to be agile and adaptive and reconfigure the way of working, just because of the pace of the change which is happening. So we can't kind of stick to our old ways of doing things. So this is definitely, I would say, one of the key challenges, at the same time one of the key implications of this crisis. And the project has a lot of activities going on. Today at 2:15, if I'm not wrong, you would have an opportunity to also look at the digital technopole. I have a slide on that. I will come back to that. And it's I think it's quite promising to see that 15 plus partners across Europe are collaborating for a very purposeful exercise. And now I would jump to an SME survey we have done with a SME network in EIT Manufacturing. So we did this survey with our partners in France and Slovakia. The Slovakian Technical University was involved, and we reached out to 70 SMEs across 20 countries in Europe. And what was very interesting, I would say, before I go into the results, was that the SMEs have a very much a proactive approach to investment in new technology. And we were speaking mainly to the managers, as well as sometimes to the business owners of these SMEs. They were very much, I would say, contrary to the popular opinion, very much open and ready to embrace new technology because of the business model change, because of the pressures they are facing maybe. Another aspect of the survey, which was very interesting, I would say, is there was no direct correlation between the size of the company and the willingness of the management to train or upskill the employees. It was very much connected to the desire of the management, and not like if a big company or an SME with a big size, it's not a given that they are focusing on upskilling. So indeed, so read through. So they have started digitalization. We have looked across sectors. There has been, I would say, very much focus on individual projects, be it machine vision using artificial intelligence, or using machine learning, as well as using new materials in additive manufacturing. But there's a lack of holistic strategy of how should we go about from say an organizational perspective. What we see as a positive indeed is that production and logistics information flow is already being digitalized, be it plant simulation in Siemens or some kind of software which is going towards digital twin. We identify opportunities mainly in these three areas, one of them being energy consumption, energy reduction. Secondly, predictive maintenance, which is going into the direction of artificial intelligence. And the third part is about quality inspection and control. And definitely we see a high need for training and upskilling for employees across the SMEs. Maybe another aspect to this survey has also been that we identified some obstacles with respect to digitalization. So digitalization has been as a lever for increasing the competitiveness, but at the same time there has been resistance or obstacles being seen from, say, an employee perspective or a management perspective. And one of them is the ROI or the economic benefits. I don't see the results of what we are doing by the end of this year. This is a common statement you might have heard, or this is something which is digitalization costs a lot of work. It's really something which would maybe reduce my competitiveness. So this aspect is also something we should keep in mind. And definitely a very big change management and a cultural communication aspect to this as well. And this is something we'd like to highlight. And if I have to kind of put it into a picture, in terms of work allocation and as well as managerial implication for designing work, it's really important to think about having jobs, which we are in a knowledge intensive economy, which has a high trend or at least a high direction towards autonomy. And at the same time, there is very much focus on learning while doing, and as well as to upskill. And it's not only about having this, I would say, scientific knowledge and a PhD, which is great, but at the same time, one has to keep on upskilling, and at the same time keep on I would say challenging the status quo is something we also realize. So maybe you would like to spend a few minutes on the digital technopole which has been launched. I encourage you to look up for the website. It's quite interesting. It will work only if you participate, and that's why it's important that you have a look at it. It's really useful across the sector, say from metal industry to construction, and there's a solid, I would say, network behind of more than 15 companies who have set it up, and the goal is to act as an ecosystem for ramping up production and for similar incidences which might occur in the future. So I invite you to look at the digital technopole. There's a session planned at 2:15 for this one. And now we'd go to quickly to talk about EIT Manufacturing. EIT Manufacturing has been part of this project, responsible for the communication. And briefly, we support innovation, business creation, and education across Europe. We have supported more than 60 projects in the last 2 years. We have a portfolio of startups across the technology spectrum. We have also initiatives, smaller calls, which are occurring. So the latest initiative, which will end on 18th of May, is an entrepreneurship challenge. So this is about SME or a company which is based in the risk countries. They would get around 50,000 euros proof of concept, I would say, fund. And the fund is meant for technology providers and SMEs to collaborate with these entrepreneurs inside the organization. So have a look at our website. If there are questions, we can send you more details on that. In general, EIT Manufacturing, the thematics are looking at, like I would say, this is not new, but looking at topics, say, from AI to automation, where there's also an increasing need and an impetus from EIT Manufacturing to talk about circular and green manufacturing, and how could human and robots collaborate together in a new setting. So this is very briefly about what we do. I got one project example which probably fits the theme of the event. We had supported a project which was ramping up air purifiers manufacturing. It was a consortium across Europe. We had colleagues from Comau and as well as from CEA involved. And the result of this project has been a startup, which is now ramping up. And we are quite proud of this project and how it has kind of also been, the technology has been patented, and this is also I would say a very much social impact as a result. What you would also see is that our drive is to deliver results quickly into the market as compared to the other Horizon 2020 vehicles. So we are very much connected to the ecosystem of Horizon Europe. But at the same time, for us, it's important that a certain pilot or a prototype which is existing to help them scale up and to take that first risk of meeting the first customer. This is our main value proposition. And if you find this relevant, feel free to reach out, and we would be happy to help. So, and this is where, if you would like to know more, one of the ways is to see our website as well as Agora. It's an innovation platform, open innovation in a way where you could also be informed, and it's right now with 1,400 plus members. So we have this QR code, but at the same time you could you could have a look at our website as well, which is agora-EIT-manufacturing.eu. So that's it from my side. Thank you for your interest. I'm curious to see the results of the quiz, and I wish you a good event, and and all the best for your future endeavors.
Thank you very much, Amardeep.
Thank you.
I'm just sharing you the results of the quiz.
Oh.
So the right to repair was 50%, and the circular manufacturing was also 50%.
Okay, so that's I would say not surprising, but very good. That's good to know. Thank you, Aniko.
Okay, and I would like to thank you, and just some personal notes on myself. Being a teacher originally, I completely agree with you that change management is very important, and also the changing of the workforce and the people's way of thinking, because unfortunately it's very, very difficult to bring them into a new mindset. And I think this is a very important feature of what you had just pointed out. So I would like to thank you very much again for these insights. And I'm just telling it to the other participants that we will have a whole session on workforce ramping up and knowledge management tomorrow, which I'm inviting everybody again here. So thank you, Amardeep, again, and let's just go on with the next presentation. Who will be Dr. Mario Miana, and he will share some insights on virtual prototyping and digital twins, which are helping repurposing product design during pandemics. Let me just introduce Dr. Miana in some words. He is a PhD chemical engineer from the University of Zaragoza. He is from ITAINNOVA, which he joined in 2002, where he has concluded and collaborated in more than 60 plus research and development projects, which were funded by some private companies. He also has got experience in more than 12 public projects funded by regional, national, and European programs. He's the co-author of 17 papers published in JCI index journals, and made 18 conferences in national and international congresses in the Europe and the USA. And since 2008, he combines his research activity with teaching as adjunct professor at the Thermal Machines and Engines Department at the University of Zaragoza. So I would like to give the floor to Mario. Please go ahead with your presentation.
Okay, Aniko, thank you for your kind introduction. And I will present the information about the best practice of how virtual prototyping and digital twins can help in the repurposing product design in times of pandemics. At the beginning of the COVID crisis, there was a a very important requirements about disinfection device in order to be able to clean up all the surface to reduce the infection by the COVID virus. So it was necessary to obtain a spraying device that could be able to perform in an effective and in an accurate way the disinfection of this kind of surface. As a result of this project, we are going to develop a digital twin that can help in the design of the spraying nozzles in order to obtain the best solution that can be obtained for the development of new spraying systems. This is the contents of the presentation. First, I will present the institute where I work, ITAINNOVA, and next I will present the physical phenomena that are involved in the spray device. After that, we will present the different products design that can be applied to this kind of system. And following the subsequent step will be the presentation of the digital twin that has been the definitive tool obtained for the design of this kind of spray nozzles. And finally, we will end the presentation with the conclusion and the future steps. ITAINNOVA is a technology center dependent on the local government of Aragon. Aragon is one of the 17 regions where Spain is divided. We are located in the north and in the east of Spain. And we have more than 35 years of experience in guiding and helping companies to be more competitive and excellent through the innovation and the technological development. We are more than 230 people. About 20% of them have the PhD degree, and we have a strong human resources in engineering. We have more or less all kind of engineering. There are mechanical, chemical, like myself, electronic, computers, telecommunication engineers, and we have a significant amount of graduates in mathematics, physics, of chemistry. Of course, we have a large number of people with formation or with strong curriculum on technical and scientific disciplines. Our work can be defined as a teamwork. It's very easy for us to work between different departments, and always we are looking or we are searching for the excellence. The work that we develop is always focused on the results, but on the results of our customers. And our customers is showing in the lower banner. Our customers can be companies, can be public administrations, can be institutions, can be professionals, entrepreneurs. At the end, we work for the society, and we look on the best result for the society in global. We have developed a large amount of innovative solutions. I will show you the innovative solution that we have developed for this kind of spray nozzles. And of course, as a public technology center, we have a clear service vocation to the society. What we provide for companies is a wide portfolio, and we can develop research and development projects with high added value. We can accompany the companies in order to be able to develop a digital transformation process, and we have technological and laboratory services in order to fulfill your specific requirements in terms of new normatives or new laboratory tests. We help in order to access to competitive public funding programs, and we can work in technology consulting. And finally, we can join in specific partnership programs in order to build up strategic alliance with our customers. And now I'm going to explain with the technical activity. And first, I will introduce the definition of spray. Why it's important disinfection sprays in order to fight against COVID? An spray is no more than a liquid, which is a liquid flow, which is broken down into small droplets. And the advantage of this kind of systems is that you can reduce infection using lower liquid flow rates. If you want to reduce infection and reduce the amount of virus inside over a surface, it's better to use as less as possible amount of liquid, so you will obtain a cheaper disinfection process. And of course, you want to obtain a disinfection process using and obtain a better coverage than using a typical tube and tracking the surface. Of course, when you use the disinfection spray, you are going to obtain all this better performance in the disinfection process. And if we want to improve the design, we have to define which are the design variables or the design parameters in order to know if our new design is better or not than the previous one. These design parameters are typical: the distribution of droplet diameters and the angle, the range, and the shape of the spray cone that is shown in this picture. There are two different kinds of spraying system. The first one is hydraulic atomization, and in hydraulic atomization system, there is a pump that pushes the liquid flow through an orifice, and this pumping, this motion provokes the breaking up of the liquid flow into small droplets. The main benefits of the hydraulic atomization is that you have to apply lower energy than the other system, which is pneumatic atomization. And the main disadvantage is, on the contrary, that you will obtain large distribution of droplet diameters compared to the pneumatic system. In the pneumatic atomization, you have a compressor that generates a high-speed airflow, and this high-speed airflow is the responsible of the breaking up of the liquid flow. And with this system, you are able to obtain droplets of smaller diameters and with a more uniform distribution. On the contrary, if you remember your thermodynamic classes at the university, you can remember that compression of a gas flow requires more energy than compression of a liquid flow. So the pneumatic atomization requires typically more energy than hydraulic atomization. In this project, we are going to focus only on pneumatic atomization. We are not going to deal with hydraulic atomization. And the heart, the main part of the spray system is just the nozzle, where the liquid and the gas are mixed. All the design parameters of the spray, for example, the shape, the range, the distribution of the droplet diameters, are always governed by the shape and the dimensions of the chamber, where both streams are mixed. You can see in the picture on the center of the slide that there is very large, very different shapes of the spray angles. There are very different concentration of the particles in the center, in a crown around the center. You can obtain more or practically all the shapes that you want using different nozzles. The other parts are the same, using the same tubes, the same compressor, but the heart, the part or the device that will govern how your spray will work is the spray, is the nozzle, and you have the nozzle analysis in this project in the picture on the right. This design has been performed in collaboration with the company Terstyansky, and I would like to invite you to join to this session that will be performed tomorrow. And the title of this session is the Electrostatic Disinfection Spray System. It will be performed by my colleague Jose Manuel Bielsa tomorrow at 10 to 11, and you can and you can have a deeper knowledge about the product design of the suitcase and the back page that has been developed in this project between ITA and Terstyansky. And now we can start with the product design itself. The first of all is the definition of the requirements. What Terstyansky asked us to give us an output about what is the performance of the spray nozzle. Okay, first of all is the droplet diameter. We want droplet diameter very small, about 8-9 microns. Remember that 1 micron is the division of 1 millimeter into 1,000 equal parts. So 8 microns are very, very small size. We want narrow and uniform distribution of droplet diameters. If you see the different distribution on the picture on the left, excuse me, on the right, we prefer the distribution on the left side because it's more uniform and we will obtain better performance results. We want as much larger runs as possible. In any case, this requirement is too tight. It's not the critical one. The distribution of the droplet diameters, the average of the droplet diameter, for example, are critical parameters compared to the run. And finally, of course, we want the lowest liquid consumption in order to obtain the most effective, cheaper solution for disinfection. In the same manner, we want the smallest airflow because if we can produce the same breaking up of the liquid flow using the smallest airflow, we can buy the smallest compressor, and with the smallest compressor, the weight of the suitcase manufactured by Terstyansky and the autonomy of the device itself will be larger. So these are two very important parameters, design parameters of the final product. So the airflow is just another requirement, and we want to be able to get the spray, the same spray characteristics using as less air as possible. Of course, if we want to meet all these requirements, we need a tool for fast and accurate design of spray nozzles for disinfection during pandemic crisis. And this is the work that we have performed in this project. What are the design variables? We have initially input variables, which are the flow given by the compressors. One of the main critical parts of this device, of this disinfection device, is the selection of the compressor, and of course we need the supply chains showed by my colleague in the previous presentation. So it's very important to obtain the right compressor that provides us the right airflow. And we can define the dimensions of the nozzle. In the picture on the bottom part, you can see the different dimensions that can be modified in the original nozzle developed by Terstyansky, and we can modify the angle, we can modify the different radius, we can modify the different lengths of the chambers included in the mixing region between the air and the liquid. The air enters into the nozzle by the top channel, which is colored in green, and the liquid enters in the nozzle by the inner channel. Okay. Which are the output variables? The output variables are first the liquid flow rate. As I have already told you, we want lowest liquid flow rate as possible, and we want uniform and uniform distribution of droplet diameters. And there is another important output variables, which is the spray angle, which is shown in this picture. Depending on the spray angle, we can cover different surface in different passing of the machine. So it's important to know in advance how will vary the spray angle with the design. And for this kind of system, we can apply two different design cycles. The first one, the classical one, is the experimental design cycle, where we first start planning a new design. We are going to draw a blueprint of the new design. With this drawing, we are going to create it by means of 3D impression. For example, we are going to build the physical prototype, and once the physical prototype is already built, we have it on our hands. We can test it in a laboratory. We can perform experimental tests and evaluate the performance of this physical prototype. Once the results are obtained, we can investigate the results and try to identify where the critical points, the critical issues are governing the behavior of the spray nozzle. And there is a classical, another design cycle that can be at this moment can be considered classical too, which is the numerical design cycle. It's very similar to the experimental one, but we are going to obtain the information not from experimental tests, but from numerical simulations. First, we have to plan the new nozzle dimensions by creating the geometry in a CAD software. Then we are going to create the mesh by using another CAD software, and we are going to create the numerical model, selecting the involved models that can represent the physical phenomena included in the picture, included in the system to be represented. And with this, we can evaluate the numerical results. We are going to obtain the pressure, the temperature, the velocity of the airflow, or the velocity of the liquid flow in all parts of the domain. You can see on the picture in black and green the mesh, all the points where the numerical computations are performed, and we can see on the colored drawing on the left the results of the air volume fraction inside of the domain. So using this representation of the numerical results, we can evaluate which is the best solution. And with this evaluation, we can investigate how the droplet diameters are modified by the different designs, and we can plan new designs in order to obtain the optimal solution. These are the two different design cycles: experimental, which is more classical, and numerical, which is the design cycle that has been reported in the last 40 years, 50 years. Okay. Difference and advantage and disadvantage of each one. For the experimental design cycle, all phenomena included for this kind of spray atomization is very easy to analyze what happens when you start with electrostatic atomization. It's just pressing a button and you can obtain the results immediately. For numerical simulations, you have to include the appropriate numerical models in order to analyze the influence of the electrostatic charge. Disadvantage of experimental tests, you have to build physical prototypes, so you have to increase the cost and you have to increase the time in order to be able to build the test, prepare the laboratory, build the prototype, prepare the laboratory, perform the test. Okay, it can take time. And there is a significant disadvantage of experimental tests is that you have knowledge limited to the measuring points. For example, you can measure the pressure at the beginning of the nozzle and you can measure the droplet diameters at a certain distance. But you don't have information of the droplet diameters, some millimeters upwind or some millimeters downwind of the measuring section. Okay. On the contrary, numerical design cycles can obtain all the information: pressure, velocity, temperature, in all positions in all the calculated domain. You have seen previously the mesh applied in this study, and you can perform analysis of what if. You don't need to buy. You don't need to build a physical prototype, but you can analyze what happens if you modify and you change, for example, water to acetone or another kind of liquid, and you can analyze what happens without testing it. On the contrary, the disadvantage of numerical design cycles is that you need validation from experimental test, and you can include a large number of numerical models, but the inclusion of new numerical model can increase in a significant manner the computational time. And moreover, there are some phenomena which can be difficult to be computed or which can require larger computational times. For example, at the beginning of this project, we started with some simulation that took about 2 weeks per case. You will see the amount of number of cases that we are going to perform. So this computational time is not affordable for this kind of design cycles. Okay, so what we are going to choose, experimental or numerical? Both. We don't need to select just one. We are going to apply both experimental and numerical in order to build the digital twin, and we are going to obtain a new tool for the design of spray nozzles. This is the roadmap. First, we are going to perform experimental tests in the initial design performed by electrostatic. And we are going to perform this experimental test here at ITAINNOVA. And with this experimental test, we are able to characterize the different flows inside of the spray system. Next, we are going to apply this experimental characterization in order to build up numerical model to represent all the important phenomena that occurs inside of the nozzles, and we are going to obtain with these numerical results the output data for the definition of our digital twin. The digital twin is just the mixture of experimental and numerical results. Okay. First of all, we are going to perform this kind of experimental test. We have two different prototypes from Terstyansky, and we are going to measure pressure, we are going to measure temperatures at different points, and we are going to measure the volume flow rate of both liquid and air flow rates. And with this, we can provide significant non-dimensional numbers that allows us a fast characterization of the phenomena included here. For example, turbulence, for example, heat transfer by convection, by conduction, by radiation, can be defined if these phenomena are important or not based on the results of the experimental test. With this initial information, we can perform numerical simulations, and the numerical simulations is performed on 3 stages. First of all, we are going to perform just airflow simulation without considering water. We obtain the airflow rate from the technical dataset of the compressor selected. The compressor say that the technical dataset say that this compressor can produce a certain airflow of, for example, 2 grains per second, considering this pressure drop after the compressor. Okay, we have this input data, and with this input data, we can obtain the pressure drop in the design circuit. We are going to simulate how the airflow is evolving along the nozzle, and we are going to measure the pressure drop between the tank reservoir of the liquid and the outlet of the liquid inside of the nozzle. This pressure drop will be applied in a water flow simulation, and this water flow simulation will provide us the water flow rate or the liquid flow rate that will be passing through the different parts after up to the reaching of the nozzle. Once that we have the water flow simulation, please take into account that first step is just airflow simulations, is monophasic. Second step is water flow simulation, is just considering the water stream. And in the third step, the air blast simulation, we are going to mixture liquid and gas domains. And with this third step, we are going to apply the water flow rate obtained in the second step, and we are going to obtain the spray angle and the distribution of the diameter of droplets in all parts, in all points of the simulated domain. This is the numerical methodology that we have developed for this project, and we have the main advantages is that the simulation of one geometry, one design case, one design point it just takes about 2 hours. So it's an affordable time. If we have to spend 2 weeks, 3 weeks per geometry, you will see that this is not affordable. Why? Because for the digital twin, we need to consider different geometries, and considering all the parameters that are involved in the definition of the geometries, you have to at least simulate near of 200 different geometries. So if you need 2 weeks multiplied by 200 cases, you need a lot of number of weeks. This is not affordable. We need to finish the digital twin as faster as possible. So what we perform is simplifying models that takes the most of the physical phenomena included, and with these simplified models, we are able to obtain enough information. This information is then obtained from the numerical results. We are currently working on the numerical results, and you can see that different design variables can obtain different atomization results. For example, when you see the geometry on the left, you can see that atomization is produced, but you can see the geometry on the right side that atomization is not produced. So the design point on the left is okay, but the design point of the right is not okay. So you don't have to build this physical prototype in order to test, and you are not going to define this design. And finally, all the numerical results are put together inside of the digital twin. The digital twin will be the tool for the design of the spray nozzle, and it will be available at the digital Technopole, which will be presented by my colleagues after this initial presentation. And how it works? Well, so first, the users can select any value of the different variables that are predefined, that are considered in the predefined intervals. And next, a reduced order model will be able to calculate the output model or the output variables from the previously calculated results. You can define any value, and you can obtain the output results considering the information obtained by means of the reduced order model. And finally, the tool will be able to show you the obtained output variables immediately. You don't have to wait 2 hours, you don't have to wait 2 weeks in order to obtain the variables. So the conclusions is that we have a new design tool for the RSS spray nozzle, fully developed by means of virtual prototyping and digital twin. We can provide to the users a tool for the analysis of the impact of the dimensions and their flow rate on the spray characteristics. And this design tool will be available at the digital Technopole. So thank you very much for your interest. And if you have any question, I will try to answer it.
Thank you very much, Mario. I think it was a very deep and thoughtful introduction of your research results. And also, as Mario has mentioned, please, you can just join us for the other presentations, because they are kind of entwined into each other and giving a comparison and some extra information to each other. So we will have some further presentation on similar topics. So if, yes, there is a question here. Mario, can you just give us an example on how digital twins work? I know it's kind of basic, but maybe there are some people among the participants who are not familiar with this technique. So can you just sum it up in very, general terms?
Yes, I cannot show you a specific example of this project. My idea was to finish it and to show a demo, but we don't have it. The computational time is too big. We need to finish all the models, and we have to build up the digital twin. But we have developed similar methodologies to other projects, and I can show you a video about an example of digital twin. But it's a process fully different. It's a thermal process about a plastic part. And I have a video.
I think it's fine. It's kind of a short session. So if you have got we've got some time now. If you can find it quickly, I think we can just take a look at it.
It's a typical question, because when you don't have the right, the final example, we try to show several similar solutions, and this is the piece, and you can modify the initial temperature. You can define all the parameters involved with the thermal molding of this plastic part, and you can obtain directly the physical properties of it. So this is performed following the same approach. We have developed a large amount of numerical results. We have developed a reduced order model, and the reduced order model is able to interpolate between the different scope between the different space of solutions in order to obtain any value, any output value inside of the analyzed range. So here,
so you are, let me just put it straight, you are going to show the video for us right now?
Yeah, cannot, sorry.
In the meantime, while Mario is searching for it, let me just try to tell you with my own words, because I also have got a background in humanities and I didn't really understand it for the first run. So basically, a digital twin is when, for example, you've got a manufacturing company and you would like to try some technical process, but you don't have the required machines or the required technology for it. And the digital twin basically will do the process for you in a simulated environment. And based on this simulation, you can have some conclusions on what will happen in your company. If I didn't say it too badly.
Yes, we can apply the methodology to new products, but it is important to define the requirements and to define the geometry and the process that define the product. So for us, it's very necessary the knowledge from the customer about their product, because we know how the numerical tools can be applied, but the requirements, the definition of the parameters, which is the important keys, can be improved if the customer give us all this kind of information. So we have developed this methodology for breaking components in automotive. We have developed this methodology for heat exchanger. It's a very wide methodology, but we need the input from the customer in order to obtain the more successful results.
I see. So basically what we see right now is the simulation itself, right?
Yeah. You see the digital twin. You can see that you are able, for example, to modify pressure 1 into different values, and the application shows directly the physical properties of the plastic. Yeah.
Yes.
And it's not necessary to calculate every point. You just have to obtain specific points inside of the map, and the reduced order model is able to interpolate.
I see. I think it was a very good demonstration. So it's always easier to imagine something when you see it and not just hear about it.
But I have prepared not to insert into the presentation because it can produce a crash.
Yeah, but it just it was a good question because it just gave us some visual introduction to it.
It's a common question because it's very abstract. The concept of digital twin, you can understand experimental tests, numerical results, but when you mix it, you obtain a reduced order model. It's so abstract.
It's kind of a very theoretical idea, but when we see it now, it's easier to understand. Okay, so I think we are getting very interactive here. Thank you very much, Mario, for this very interesting presentation. And as I said, if you have got some further questions, you will find us later on either in the expo or at the Digital Technopole, and also you can contact us directly. So thanking you again. And I'm calling our last presenter to the stage, who will be Gabor Terstyansky.
Thank you very much. I am here.
And let me just introduce you shortly to our audience. So Gabor will show us a cloudification as a good answer to the problems which can be risen during a crisis situation. So let me just tell you some words about Gabor's background. He's from the University of Westminster, from the University Research Center for Parallel Computing. Gabor's research interests include distributed and parallel computing, focusing on targeting research issues of big data and cloud computing. He has been involved in more than 15 research projects, either as a principal or a co-investigator. He published over 140 papers at conferences and journals, and he supervised more than 10 PhD students. Um, he taught several BSc and MSc modules on distributed computing, such as distributed computing, service-oriented architecture, and web services. So, Tamás, please just go ahead. The floor is yours.
Okay, so thank you very much. So basically, this presentation is about a service which we are providing to address unexpected events. I already had one unexpected event because when I tried to upload my presentation, the slides are blank. As a result, Elena will help me to move in the presentation from one slide to another. Okay, so next slide, please. Okay, so there are quite a lot of more serious unexpected events. For example, the COVID pandemic, one of the reasons why we are having the Coversa type project, the war in Ukraine. To address these unexpected events correctly, efficiently, and quickly, it's a big challenge for companies. Or they have to make decisions in a short time, and if the decisions are wrong, they are in a real trouble. To help the companies, we can there are different solutions such as modeling, such as simulation and optimization. These approaches help companies to make the right decision. So this is the positive side. The negative side is that to do modeling, to run simulation, or to do optimization requires some extra efforts, requires some extra computing resources, need some extra knowledge and so on, which companies might not have. Next slide, please. Okay, so what we are offering a so-called cloudification service. In this case, we are talking about a cloud, which is nothing else than a pool of compute and data resources. These are not the clouds you can see on this slide. Next slide, please. Okay, so how can a cloud help? Okay, so previously companies had to buy hardware resources, had to buy software licenses, then they have to employ staff, and then they have to use the purchased hardware and software resources. If they use a cloud, they can go for a pay-as-you-go service. Okay, so next slide, please. What does it mean? Modeling, simulation, and optimization is a complex process. In many cases, these approaches require extra computing data resources. They need a specific software packages. Okay, so if these resources are available, they can model or simulate, for example, manufacturing processes. They can simulate supply chain and so on. So what is the major problem? That the entry barrier is quite high. What are the challenges? I already mentioned they have to have hardware resources, and in many cases, if the computation is highly demanding, it's not enough to buy one or two desktops. They need software licenses, which are not cheap. They need some expertise to develop the model, to adjust the simulation software addressing their specific requirements. What is the solution? They can use the cloud. If they use the cloud, then they can use the available cloud resources such as processors, such as data resources, such as networking resources. If they want to use a cloud, they need a new licensing policies, and these licensing policies is available. So this is the positive side. But in order to use the cloud, they need a specific expertise. They have to create a cloudified version of their software. They have to deploy this software, and then they have to use this software. Next slide, please. Okay, so who we are. So basically, we are at the University of Westminster. It was one of the first polytechnics in UK. It became a university in late 20th century, and it's a large university with almost 20,000 students from 170, representing 170 nationalities. The university has a very intensive research cooperations with research organizations and companies. We are from the Research Center for the Parallel Computing. So we are involved in research on distributed and parallel computing infrastructures. Currently, we are focusing on cloud, fog, and edge computing. So we also provide application support for non-IT users. For example, we help them to describe their applications, deploy and run their applications in the cloud. Next slide, please. So what we are doing? What are we doing? So first, we sit down with the customers, for example, with companies. We analyze the application. It is basically a problem statement. Then we describing the application. We use a specific template where we describe the hardware resource requirements, data resource requirements, where the input data should be uploaded, where the results will be available. And using this description, which is a template based, we deploy and run the application. So basically, all these services are provided as a consultancy. Next slide, please. Okay, so what is the technology behind this consultancy service? We developed the Mikado, and next slide, please. And what does it do? So basically, at the top of the slide, there are the applications. The applications are implemented as services. And what we want to do, we want to run these applications, deploy and run these applications on the cloud. So there are two options. Either do it manually, and then if there is a change in the cloud, then you have to adjust manually. Mikado offers an automatic solution. we monitor the application execution. And if there is a change, for example, there is a need for more resources, we can make those resources available automatically. Why it is important? If we don't adjust the available resources, then there could be two problems. The application execution could slow significantly, or if there is not enough resources, or it could be too expensive if the available resources are not used at all. Next slide, please. Okay, so what is inside the box? I am not going into details. So basically, there are one important component or entity. On the left side, you can see the application description template. I already mentioned the template 2 or 3 slides previously. The important point that we create this the application description using this template. If this application description is available, then both the deployment and execution on the cloud is done automatically. Okay, so let's not to be lost in technical details and move to the next slide. Next slide, please. Okay, so in co-versatile project, we cloudified two supply chain simulations and two manufacturing process simulations. I am going to give a short overview of the supply chain simulation model. So because of COVID, it was a real challenge for many companies to adjust their supply chain to the changes in demand and in changes in offering. So we work together with IML Fraunhofer. They are experts in supply chain simulation. They created the model of the supply chain. For example, the one of the co-versatile partners, Demcon, and then we cloudified this application. The cloudification meant two steps. First, we sat down with IML and produced the application description using the application description template. And then we containerized this application, then deployed and executed this application in the cloud. Next slide, please. Okay, so this is an example. So the supply chain simulation is complicated enough. The cloudification is complicated enough. What is the output for the companies? For the companies, basically, there is a page, and they have to upload their input data, and then clicking on a button, they can run the simulation. And then the results will be available. So what is the major advantage following this solution? So once they have a model, the supply chain model, it can cover quite a lot of scenarios. If there is a change or if there is an unexpected event, then they can modify in most cases they have to modify the inputs, and then they can rerun the application, the supply chain simulation again and again, and they can get the corresponding simulation results or the outputs. And based on the outputs or the results, they can make a decision what to change in their supply chain. Next slide, please. Okay, so further, please. Okay, so you can see the results, and the results what you see here represents what in this case DEMCON wanted to have about its supply chain. Next slide, please. Okay, it is so basically that's all. Thank you for your attention. If you have any questions, I am ready to answer your questions.
Thank you very much, Gabor. I don't see any questions in the comment section, but this is not such a huge problem right now because it's already 2:15 and we are a little bit late with our timing. So I would like to thank Gabor again, and
thank you very much.
And while I'm just closing this session, or before I'm closing this session, I would just like to tell you some more words about our activities. So you might have heard we mentioned the Digital Technopole several times. Those of you who were here with us yesterday have seen the presentation about the Digital Technopole by Sebastian, who is the representative of Glasgow and one of the partners in the co-versatile project. So the Digital Technopole is one of our main deliverables, which is basically an online marketplace, and it can be said that this is a website. Elena, can you just bring up the Digital Technopole slide next? Yes, here you can see the Digital Technopole's address and its entrance screen. So the Digital Technopole contains all the results of the co-versatile project, and this is the place where you can also get in touch with us after the conference. Not like in other projects, the Digital Technopole will not be closed down after the end of the co-versatile project, but it just it stays there for hopefully for several years after our project finishes, and it will contain several places, features, forums, consultation opportunities, courses where you can get in touch with us and get familiar with the results. Also, as you can find it in the comments, you have got the opportunity after registration to request for a match, because one of our tasks is, or most important goal is, to match you with those partners of the co-versatile project who has got the results and the products which you might be interested in. So that's why I said after Gabor's presentation right now that, for example, the Mikado software is available through the Digital Technopole. So after registration, you can get in touch with us. You can take a look at the different solutions which are on the plate. And also, if you click on partners, you can check out the co-versatile partners. And if you go to matches, you have to click on the create new match option. And then you will have the opportunity to get in touch with that partner you are interested in. As I said, matchmaking is also one of the outcomes of our project. So when you are requesting for a match, we will get in touch with you to offer free consultations to find support which is tailored to your company's requirements. After assessing your business needs, we will create a user journey And it will include the development of a customized strategy and an action plan. And after this analysis, we will suggest you some specific solution or provider of the digital technopole, which will fit your individual needs. And when I'm saying we, I'm referring to my company, which is innomine. We are also part of the co-versatile project, and this will be innomine's task to join you with this innovation journey and help you with finding the most significant or most suitable solution from the digital technopole's platform. So we are waiting for you at the digital technopole. It's already open, so after we are finishing the session here, you will have the opportunity to take a look at the digital technopole, get familiar with the features. So first you have to register, and after registration you can just browse our palette. And after you got familiar with the digital technopole, you will see that from 2:30 to 3:30 we will be live at the expo. The expo is here. It can be found here in Hopin on the left-hand side of your screen. That is the place where you can get in touch with all the other participants of this conference. When you enter the expo, you will have the opportunity to take a look at the presenters' company's introduction. So all of the co-versatile partners have a so-called booth, which is like a booth in real life, but now we are offering it for you online, where you can see a short introductory video about the partner, and you can see who is in the booth. And you can initiate some talks with the representatives, either right now during this 1 hour, or you can schedule a talk or a chat later on in another time, which is more convenient for you. And also, last but not least, you will find the so-called manufacturing settings in the expo booth, with all of these examples which we've been talking about in the past 2 days, about the face masks, the respiratory devices, and the sprays also. So that was our session for today. So after you have visited the digital technopole, you can meet us until 3:30 in the expo. And I would just like to encourage you to join us tomorrow for the final day of our SME Resilience Days. In the morning, we will concentrate on the flexible future of work. So you already heard some mentions and some presentations which were referring to the changing workforce and the changing requirements. So we will dedicate a whole session tomorrow from 10 a.m. to this topic. Between the two sessions, again, during the lunch break, you will have the opportunity to visit the Digital Technopole and the Expo. We will be there live. And from 1 o'clock, the last, but maybe one of the most important features of our conference will start, which will be about supply chains. So that will be our final presentation. And also I would like to call your attention that we will distribute some evaluation forms during the conference, and also we have got a brochure which you can also download from the Hopin page and also from our co-versatile webpage, where you can find all the introductions of the partners and our presenters as a downloadable PDF for you to take home as a kind of reminder and a publication from this conference. So I would like to thank you very much again for your attention. And as a closure, let's just watch a short film about the co-versatile project. Thank you very much and see you in the expo and tomorrow at 10 o'clock. Goodbye.